So we are going to use Excel to make some line graphs of some data. The best data for a line graph is sequential data or time series data. You can see the example data we have is collected over a number of years, and in this case represents revenue in thousands of dollars. To create a line graph, we're going to highlight the data. We're going to go to Insert, and we can use recommended charts or the line graph button specifically. But let's start with recommended charts. For this kind of time series data, you should get the line graph as one of your options. You can also go to the line option under all charts and see a variety of different line graph choices. We'll explore some of these in the next section of this video. But for right now, we want to take the standard one. Be careful that the years are along the bottom and your values of, in this case of revenue, go vertically. You do not want the line graph that uses line numbers and plots the years and the revenue as separate pieces of the graph. And so then we hit OK. Now before you try to make adjustments to the graph, including features and things like that, it's good to explore and make your graph look nice. So you can select various options for the design. We have too much data here to want to use particular values in our graph. Let's see, what are some other options? I like the quick layout button. Can also provide additional options. Some of them include the numbers. Some of them have axis labels. If you have a few values, this one's not bad. We have way too many for that. You can get some various features. I think I'm going to go with this one. When we're finished, we would like to have axis labels on both axes. This is the year. This is revenue, thousands of dollars. Revenue 1960 to 2017. So we can see from our data, the data goes actually up to 2018. If we want to eliminate specific options, the Add Chart Elements button will allow us to eliminate the legend or include the legend. There's only one value of data in this set, so we don't have to worry about the legend. We have more sophisticated options like adding trend lines if we want to make predictions about where revenue is going to go in the future. Generally, we use that for scatter plots. The option with the numbers pasted on each point is called the data labels. This is too busy. We don't want that included here. The data table is the option that lists values along the bottom. Again, there's too much information here, so we don't want to use that. Error bars can be useful, but not in this context. So these are all options that we can include, but generally we want the axes to display, we want the titles, and we want the chart title. Grid lines are somewhat optional, and you can use those if you want. And there are various other features that you can apply in order to make the graph look at any way that you want. But this is a good graph. Descriptive title, axis labels, clear and easy to read. Now, line graphs can also be used to display multiple data. And so if we go to my second sheet, we have the same kind of information. In fact, company A data is the same data that we had in our first sheet. But now I have 3 additional companies that I want to plot. I can select all the data and put all of the data in one graph. Now, exactly how much data you can put into one graph is going to depend somewhat on the kind of data you have. If the graph overlaps each other a lot, then this is generally a bad idea to put more than 1 or 2 values into any particular graph, because it makes the graph particularly difficult to read. In this case, the data starts out similar, and then you can see there's a general deviation, which keeps the lines very separate from each other. And so this is not a bad way to graph all 4 of these datas in the same set. But again, it depends on the kind of graph that you have. Now, if we go to the line graph option, we have quite a number of different options for our line graph. Now, some of them are terrible. So this is not one that we would want to use. This one, as we noted before, plots the years as a separate variable, and we don't want that either. But some of our other options, slightly different format. This one converts them to percents of the data. And so it treats the largest company as 100%, and it plots the other values as a percent of the largest value. This one plots points at each of the locations where we have a value. So if you miss anything in particular, you can see where that prominent change takes place. This one is also very similar. This one is similar to that other one that we looked at, where the final column is treated as 100% and the others are plotted as percents of the total. And then there's a 3D option, and this is one of those things that I really want to caution you against using. You can see this graph is in perspective. And so if we were to select this graph, it actually makes the graph more difficult to read, in part because these lines are not lined up directly against the axis. And so it's hard to see exactly where the values are exactly projecting against the background. We have also limited options in terms of what our layouts can look like. But 3D is generally something to be avoided. We can change the chart type and then select the one that we like. Now this one's pretty decent. We're going to add axis labels. This is the year. Revenue, thousands of dollars. And then revenue by company, 1960 to 2018. So I also want to make one last note about one of the graph types, the line graphs that we were skipping over before, and that is these second options, both with the dots and without the dots. Now this graph looks superficially similar to the graph that we ended up with, but it's actually a little bit different. And so I want to spend a little bit of time just commenting on what this graph does and why you may want to avoid it. Now what this graph is going to do is, unlike our first graph, where it is plotting the actual values of the data on the axes, and then if they overlap each other, great, and if they don't overlap each other, that is also fine. you'll see that over in the corner that in fact at around the 1960, they all start out about the same and they are in fact overlapping each other. Now with the second graph type, what happens is they're going to add the values together. And so as the graph increases, they are going to keep the data separated by stacking the graph. So this separation from the gray line to the yellow line is going to represent the value of the yellow line, so that the top bar here is now representing the total of all of the companies and not just the revenue for the one company individually. So you can see that if I select this first graph, the largest value for the company D is just below $1,000. But if I select this graph, the largest value for company D appears initially to be somewhere between $1,500 and $2,000. And again, this is because the graph is stacking the data on top of each other. It is adding up all of the values together. So there are certainly reasons for doing this if you're talking about percents that are adding up to the total of 100%, or maybe you're talking about departments within a company and you want to see what the total revenue for the company is. This is a way to keep data separated from each other, but it can be misleading if you don't label the company, the type of graph that you're using, the stacked graph like this, very carefully, because people will not interpret it as being stacked. They will interpret it in the same way that they would normally interpret this graph, where each line, each value represents that one company, not the sum of all of the previous companies. So it is an okay graph and it does work in certain contexts, but like the 3D graph, unless you have a very specific reason to use it, you should generally avoid using it.